Hello, welcome to my YouTube channel. In this video, I'll be teaching how to distinguish between polar molecules and nonpolar molecules. I'll start with some basic definition. Polar molecules are molecules that have unequal sharing of electrons, creating a partial positive or negative charge. Nonpolar molecules are molecules that have equal sharing of electrons, resulting in no net charge. And because of this, polar molecules can only dissolve in polar solvents. Example is water. Why nonpolar molecules can only dissolve in nonpolar solvents. Examples of nonpolar solvents include ether, benzene, xylene, toluene. How can you tell if a molecule is polar or nonpolar? It is easier if you know what to look for when a molecule is nonpolar before you know what to look for when a molecule is polar. The first category of nonpolar molecules are molecules that are made up of one element. Monoatomic atoms, diatomic atoms that are made up of a completely positive one element are nonpolar molecules. Examples include the noble gases such as helium, neon, xenon, argon, diatomic molecules such as hydrogen, oxygen, nitrogen, chlorine, fluorine molecules. They are also nonpolar molecules. The second category to look out for is a molecule that contains only carbon and hydrogen. So when you see a molecule that contains only carbon and hydrogen, they are nonpolar molecules. Examples include methane, CH4, ethane, C2H6. These are nonpolar molecules. Ethene, C2H4. Or you write it like this: CH2 double bond CH2. So these are molecules that are composed of only carbon and hydrogen, and therefore they are nonpolar molecules. The third category to look out for is molecules that have symmetry. Examples of molecules that have symmetry include carbon tetrafluoride, there is a central carbon atom and 4 fluorine atoms attached to it. So this is an example of a nonpolar molecule because it has symmetry. Sulfur hexabromide is another nonpolar molecule. Sulfur atom at the center, then 6 bromine atom attached to the central sulfur atom. Is the presence of symmetry, so it is a nonpolar molecule. Another example is boron trihydride. These are examples of molecules that have symmetry, and therefore they are nonpolar molecules. If the molecule lacks symmetry, will it always going to be a polar molecule? Well, it depends on the electronegativity difference. If the EN difference is less than 0.5, then the molecule is nonpolar. But if it is greater than 0.5, the molecule will be a polar molecule. An example is iodine bromide. Bromide has an electronegativity value of 2.8, while iodine has an electronegativity value of 2.5. So the electronegativity difference between both is 0.3, and therefore it's a nonpolar molecule. So another example, bromine chloride. Chlorine has an electronegativity value of 3.0, while bromine has a value of 2.8. So the difference between both is 0.2, which is less than 0.5. So it's a nonpolar molecule. So what are the things to look out for to know whether a molecule is a polar molecule? First thing to look out for is the presence of hydrogen bond. So when you see a molecule that has hydrogen bond, it's a polar molecule. Okay. Hydrogen in direct combination with nitrogen, oxygen, or fluorine, and it's a polar molecule. Example of polar molecules includes water molecule itself, ammonia NH3, hydrogen fluoride HF. These are polar molecules because of the presence of hydrogen bond. Other examples include CH3NH2. Even though the presence of carbon and hydrogen bond makes it nonpolar, this NH2 makes it a polar molecule because of the hydrogen bond. CH3OH. The CH3 bond is nonpolar, but the presence of this oxygen and hydrogen makes it a polar molecule. CH3COOH. Once again, the hydrogen bond between oxygen and hydrogen here makes it a polar molecule. So when a molecule lacks symmetry and the bond is polar, the molecule is a polar molecule. An example is CH3F. CH3F. You notice that this example is similar to this example here, carbon tetrafluoride. But the difference is that there are 3 hydrogen bonds attaching to the carbon and 1 fluorine bond, so it lacks symmetry. This molecule here is nonpolar because there is the presence of symmetry, so the dipole moments cancel each other, but here the molecule lacks symmetry. Another example is we have a sulfur atom and a carbon and an oxygen atom attached to a carbon atom. Then the molecule is a polar molecule because it lacks symmetry. And also, if you take a look at the electronegativity difference, sulfur has an electronegativity value of 2.5, carbon has an electronegativity value of 2.5, while oxygen has an electronegativity value of 3.5. So even though the bond between sulfur and carbon is nonpolar, because the difference between them is less than 0.5, the bond between carbon and oxygen is polar, which makes this whole molecule a polar molecule. 3.5 minus 2.5, that is 1.0, so the electronegativity difference is greater than 0.5. Sometimes the shapes of a molecule also determines its polarity. An example is NH3. Even though there is the presence of hydrogen bond, the shapes also make it. The shape also makes it a polar molecule because it is bent shape. So take a look at this example. This is an example of a polar molecule because of its bent shape. Meanwhile, carbon dioxide here is an example of a non-polar molecule because the shape is a linear shape, while this one possesses a bent shape. You discover that this is similar to this, but the difference in both molecules, what makes one polar and the other non-polar, is the shape of the molecule. These are the basic things to look out for to determine whether a molecule is polar or non-polar. So let me quickly do a quick review. The first category of non-polar molecules is a molecule made up of one element, monoatomic atom, diatomic atoms, a molecule that is made up, that contains only carbon and hydrogen, then a molecule that has symmetry. They are all non-polar molecules. Why polar molecules are molecules that possesses hydrogen bond. So when you see an element that has hydrogen bond, it's a polar molecule. Then when the electronegativity difference is greater than 0.5, it is a polar molecule. When the electronegativity difference is less than 0.5, it is a non-polar molecule. And lastly, the shape of a molecule also determines its polarity. I hope this video has been able to help you concerning how to distinguish between polar molecules and non-polar molecules. I wish you the very best in your general chemistry course.